Hi and welcome back. In this lecture I'll show you how to put together your first circuit, write a sketch for it and then upload the sketch to your Arduino to make it all come to life. This circuit will make an LED light to blink on and off. It's equivalent of the Hello World program in the world of hardware. In the process of getting this circuit to work, you will learn some basic Arduino programming commands and structures, what the digital output is, and of course, what is an LED. So let's start with that actually. What is an LED? LED stands for light emitting diode. It's a simple semiconducting device that can emit light. A semiconductor is an amazing material. You may know that a material like copper or gold allows for electricity to pass through them easily. These are known as conductors. Other materials like glass and plastic block electricity from passing through them, and these are known as insulators. A semiconductor is in between conductors and insulators when it comes to conducting electricity. The amazing thing about semiconductors is that its conductivity can be controlled with a bit of deep knowledge of quantum mechanics. Now, quantum mechanics is an exciting topic in physics, which unfortunately I'm not really qualified to talk about, but I still encourage you to look at it on your own. LEDs are specially constructed to allow the light produced to escape outside of the device through a transparent, usually plastic material so that we can see it. Diodes come in various colors and sizes, but red, green, blue, white and yellow are the ones most commonly found. You can put together a red, green and blue LED and what you get is RGB. An RGB LED you can use to produce almost any color you can imagine. Another thing to notice about diodes is that diodes are polarized devices. In a polarized device, there is a correct way and an incorrect way of connecting it to your circuit. If you connect a polarized device to your circuit incorrectly, at least the device is not going to work, but in some cases you can actually burn it. Here's what an LED device looks like. Notice that there is a short and a long pin. The short pin is called the cathode, often noted with a K, and should be connected to the negative minus voltage. The longer pin is called the anode, often noted with an A, and should be connected to the positive plus. Other examples of devices that are polarized and use similar or the same terminology are transistors and certain types of capacitors. Symbolically, an LED is depicted like this. Now, the basic characteristics of a diode is that it is a semiconducting device that allows the flow of electricity, that is electrons, only towards one direction. Think of it as the equivalent of a plumbing valve that allows water to flow only in one direction. So we use diodes in situations where we want to restrict the direction of electricity. Diodes are used in a lot of applications like the conversion of current from alternating to direct, or in radio transmitters for the modulation of signals, and many others. The symbol of a diode is almost the same as the symbol for an LED. The only difference is the presence of these three little arrows which show that light is emitted from the LED. Now let's go ahead and experiment with an LED. We've got the background theory behind this, so we're going to go ahead and do an experiment. The aim is to become familiar with plugging components into the breadboard, uploading and running a sketch on the Arduino. In our first sketch, we'll simply make an LED blink on and off. Here's a diagram for the circuit, and I'm going to show you now. Okay, so let's get started with this. We've got a completely blank slate. Got my Arduino Uno here, a breadboard, bunch of wires, some LEDs and a couple of resistors. So I'm going to get started perhaps with the LED. I'll put that on the breadboard first. Now notice here that the LED has got 2 pins, long and short. The way that I remember how to plug that into the breadboard is that the long goes for the positive voltage, the short goes for the negative voltage. So a longer pin goes for a higher voltage than the shorter pins. Just an easy mnemonic way to remember that. So I'm going to start by plugging the LED right here. Now the next thing to do is to put a resistor in series with the LED. Now the resistor protects the LED from allowing too much current to flow through it. And if that happens, then the LED potentially can be damaged. Now a red LED like that is quite happy if you use a, say, 100 or 150 ohm resistor. So I've got a couple of resistors here, but I'm not sure which one is which. So I'm going to use my multimeter to measure them up. So I'm going to go for the, say, 200 ohm maximum, because I think those resistors are smaller. So let's check the first one. So this one is 68.5 ohms. Might be a little bit on the small side. What about this one here? This one, yeah, 179 point something. That would do a little bit better. So I'm going to take this resistor, and remember this was the short pin. I'm going to plug that, say, here, the short pin column, and then the other side I'll plug it into the blue rail on the breadboard, because the blue rail eventually is going to be connected to the ground pin on the Arduino. Speaking of the ground pin, let's do that next. I'm going to take a black wire. As much as I can, I try to use black for ground so that it's easy to identify which wire goes where. Look for the ground pin on the Arduino, which is, there's two here, so I'll just use either one and plug it in here. Finally, we're going to connect 5 volt positive voltage to the long pin of the LED. So long pin is here. That's column 15 on my breadboard. Could be different to yours. And I'm going to plug that into pin number 9. So in my sketch, I'll be using pin number 9 to control the LED. So that's about it with the hardware part of this experiment. So put the rest of the wires away. And then we're going to move on to the Arduino IDE.